Okay, hi guys. My name is Faizal Musyarof. Uh, with my ID 10 1244 0014. I'm from a class EF 48 International. So here I will report my final project statistics. Uh, as we can see here, this is my data. So I take the data from the plant uh, named PETASITUS hybridus. So this is my data. This is how the plant look in here. How do I collect the data? Here's the video. So first I measure the length of the leaves, and then I measure the width of the leaf, and then I collect it into the data. So first, this is our data. We have 15 data in here, and then next we go to R Studio. In here, we can make a summary, data summary. This. So if we run the code here, we got for the length or panjang have a minimum 515, and then the first quartile we got 10 centimeter. For the median we got 12.50 centimeters. For the man we got the 12.63, and the third quartile we got the 15 centimeter, and maximum we have 23 centimeter. And for the width or lebar, we got the minimum 4 centimeter. For the first quartile, we got the 12.12 centimeter. For the median is 15.25 centimeters, and for the man we got 15.35. For the third quartile, we've got 70 centimeter, and for maximum we've got 30 centimeter. And then we've got the standard deviation for the length and for the width in here. So we get to the next that are histogram. If we run the data, so we've got the histogram in here. So as we can see, for the histogram, we got two histogram of the length and histogram for the width. Uh, if we compare this histogram, the following histograms show the distributions of the two continuous variable. That is panjang or length and lebar or width. The distribution of panjang or length is a bit right skewed. The highest frequency are between 10 and 50, which might be considered the most frequent range for leaf length. For values above 15, there is a sharp drop in frequency with very few cases between 20 and 25, possibly outliers. The value range from approximately 5 to 25, with the highest density between 12 and 15. In contrast, the distribution of the lebar or the width is rather symmetrical, but with a slight right skew. Most values lie within the range from 10 to 20, with the highest density falling between 15 and 20, representing the most frequent interval for leaf and width. Like the length data, there are sparse values below 10 and above 20, indicating perhaps rare case or outliers. When comparing these two variables, the length and the width, the range is similar in overall range, roughly between 5 and 25, with mid-range clustering for both above histogram. However, the length or data panjang peaks earlier within the range of 10 to 15, while the data lebar or width peaks later within the 15 to 20 range. The, the distribution of data lebar or the width is kind of symmetrical and balanced when compared to data panjang or length, which will be more skewed. Nonetheless, further analysis, such as further checking into descriptive statistics and analysis, may define a correlation between length and width within the data. In fact, the development of these patterns or any environmental or biological determination is a matter for the allocation. And then we back to the R studio. Uh, as we can see here, we have the code for make a plot. So when we run it, we got a scatter plot with regression line like this. As we can see here, by showing in the scatter plot that been panjang daun or the length, and that of the lebar daun or the width of the leaf, that with a strong positive relationship exists that uh, can be quite rightly situated around a fit regression red line. If there were a corresponding change within the width of a leaf with such an increase in the length of leaves, most of the explained variation in this form would have just made a correct assertion toward a relationship. Approximately near linear approximation between these two included variables with a good fit regression line. The observed values of leaf length range from about 5 to 25, while those of leaf width range from about 10 to 13. Again showing the proportional increase in this dimension. There is very little scatters, and the point cluster tightly around the regression line, indicating a strong correlation. There are no obvious points that could be considered significant outliers or deviation from the trend. This will therefore suggest a strong relationship where the dimension of leaves scale together. Uh, and then we back to the R studio. We we want to calculate correlation, and then we have the code here, and then we see below we got 0.9363381 is shown here. The correlation uh, coefficient of 0.9363381 indicates a very strong positive linear relationship between two variables, suggesting that one variable increase, the other tends to increase as well. This high value reflects a significant and consistent relationship, such as between leaf length and width, where longer leaves are generally wider with correlation values ranging from min 1 to 1. This coefficient being close to 1 significance a near perfect positive correlation, highlighting a strong degree of predictability between the two variables. However, while the correlation demonstrates the strength and direction of the relationship, it does not imply causation, as other factors may also influence this association. Additionally, the coefficient assume a linear relationship, so nonlinear pattern might not be accurately captured. And then we back to the R Studio. Here is we have the code to generate a box plot, and then if we run it, we've got the box plot here. The box plot is will look like this. All right. So from the box plot shows the relationship between width, lebar, and length or panjang, where group data from the different width interval shows the variability in length. Overall, there is a general upward trend, where larger width values correspond to greater lengths, which indicates that the variables are positively related. Each box plot reveals a different width group with interquartile range lengths over the box and whisker extension showing variability outside it. Outliers are provided as single points and across some groups, with most of that in middle width range. The within group variability is different, with larger width interval, such as lebar 28, having more concentrated length values and smaller variability, while groups like lebar 20.5 cm have wider spreads, indicating greater variability. Overall, the position of the box plot shows a clear progression of length increasing with width to support a proportional growth relationship. And then we go to the conclusion. So the conclusion, the analysis of leaf dimension through histogram, scatter plots, correlation coefficient, and box plots reveals a strong positive linear relationship between leaf length and leaf width. Both variables display a comparable range, but with distinct distribution patterns. Length exhibits right skew, while width is more symmetrical. The scatter plot confers a tightly clustered linear relationship with minimal outliers, and the correlation coefficient of 0.936 further substantiates the robustness of this association. Box plots illustrate proportional growth and variability within which group, reinforcing the consistent trend of longer leaves being wider, while the results emphasize a predictable relationship. Further statistical exploration, including regression analysis and outlier investigation, could provide deeper insights into the biological or environmental factor driving these patterns. Overall, this study highlights the interconnected growth dynamics of leaf dimensions with strong potential for predictive modeling. Okay, thank you for listening to my video. And then see you.